Okay, try with me. Here's just an example problem. This is something you should know how to do. If I have x to the third times x to the fifth, what do you do with those exponents? Add them. Yeah, and you get what? X to the eighth. In the same way, when you have logarithms and you have multiplication, you are going to add them. Okay, so if I have m times n, then it becomes two logarithms that get added. So it's going to become log base b of m plus log base b of n. It's the exact same kind of properties as what you had with exponents, because logarithms are just a different way to write exponents, okay? The words that you need to get used to seeing over the next few days are condense and expand. When you see the word condense, condense means to make smaller. So if I'm condensing these, I see a plus sign, which means I'm going to multiply the m and the n. So it becomes log base 2, and then I would do 7 times 4, which would become what? Log base 2 of 28. Yep. So you would simplify it if you can. If you can do that multiplication or division or whatever you got, in this case multiplication, then please do it. Okay, so on number 2, this time we have, again, a plus sign, so multiply. There is not a base there. We talked about this yesterday. If there's a base that is missing, what base is there? 10, log base 10. That's the common log. So log base 10, and it is 25 times 4. You can simplify that. That becomes log base 10 of 100. Okay, I'll help you set up number 3 and then see if you can finish it by yourself. You've got two logarithms. We're going to condense it and combine it into one. So 2x times 4x squared. Can you combine that? If you don't use the word condense a lot in your life, I don't know if this is in your pantry, but it's in mine. Like sweetened condensed milk, if you've ever seen that. It's like you take milk and you add a bunch of sugar to it, and then you condense it down into like a little can, and that's what they use to make like caramel and stuff like that. Okay, fun fact. So please check your work here. If you combine those together and multiply, you get log base 4 of 8x to what power? To third. Good job. If you have that, you can go on your way. Okay, let's look at number 4. This is expanding. So to expand, if you ever had like braces, expanders, or what they use to like space out your teeth. So you're going to space it out and spread it back out. So log 6, we can rewrite that as, okay, I can rewrite that as, what are some factors of 6? 3 and 2, right? So we can rewrite this as 3 times 2, and normally I'll like give it to you, but you can also make it up if it's not given to you. So 3 times 2, which then we would space out or expand by putting a plus sign between them, and it would be, this is base 10, so log 3 plus log 2. You could also have done like log 1, right, and log 6. Would also get you back to log 1, log 6 would also get you back to log 6. Okay, so look at number 5, kind of similarly. What are some factors of 45? 5 and 9. Close up. Yeah, 9 times 5. We can then rewrite this as, with a plus sign in between to space it out or expand it, log base 7 of 9 plus log base 7 of 5. Okay, the last one does give you the factors already, so you've got 5x, so you're going to do that expansion, right? So 5 times x Can you please try it on your own? How would you expand this out with a plus sign? Try it and then check it with the board. I should have 2 logs with a base of 2. Like log base 2 of 5 plus a log base 2 of x. What you know about exponents, and then we'll take that knowledge and apply it to logs because they're basically the same. If I have something like x to the 8th over x to the 3rd, how do I get my simplified expression? Subtract them, right? You subtract your exponents, which would get me x to the 5th. Okay, so in the same way, when I have division with logarithms, I am going to subtract, okay? So here, if I have log base b of m divided by n, I'm going to do log base b of m minus log base b of n. Okay, so we're going to first rewrite this just with division. I see subtraction, so I put that, condense it back together with division. So log base 3 of 24 divided by 8. And then obviously that can simplify. What's 24 divided by 8? 3, so it's log base 3 of 3. Big 3. We'll do number 8 together, and then I'll have you try number 9. This time you have log base 2 of 15 divided by 15. Wow, that doesn't look like a 15. What does it simplify down to? 1. Can you please try number 9? Okay, so you've got x to the 9th over x to the 2nd, and then you can simplify that a little bit. How do I simplify stuff like this again? Subtract your exponents, log base 4 of x to the 7th. Huzzah. Okay, we will do number 10 together, and then you'll do 11, 12. On number 10, it's asking you to expand it out, meaning like space it out. Obviously, on number 10, it doesn't give you the divisors, and so you can make some up. What are some things that you can divide to get 4? 8 and 2, we'll do that. There's a lot of answers to that. So we'll do log base 8 of 8 divided by 2. And if I have 8 divided by 2, there's a lot of things we could have put there. Then I would expand it out with subtraction, right? So log base 8 of 8 minus log base 8 of 2. Can you please try 11, 12? Log base 1 minus log base. And then number 12. So please remember, if you do not see a base, it is a 10. You do not need to write in the 10. It is implied. Just like when you have an x, we would know that there's a 1 in front of it. You don't need to write the 10. So the n comes out in front, and I'm left with log base b of m. So if there's an exponent on the of thing, then bring it out in front. So that's your rule, is bring the exponent in front, okay? Okay, so on 13 through 15, you are condensing and you're gonna move it back. So if I have a 5 out in front, I'm gonna take that and put it back on the 2 and raise 2 to the power of 5. So it becomes log base 4 of 2 raised to the 5th. And this is where you can use your perfect chart if you have it out, or use your calculator. This can simplify. We wouldn't want to leave it like that. We can simplify it. What is 2 to the 5th? 2 times 2 times 2 times 2 times 2, 32. Or you can use your calculator, right? 2 raised to the 5th is 32. Ciao. On number 14, it's not going to simplify quite as far because you bring that 7 up to put it as an exponent, and it becomes log base 2 of x raised to the 7th. And you can't really do anything else. You can't simplify that any further, and so that's your final answer, okay? Okay, I love number 15. This is such a good review. Take 1/3, put it back as an exponent. It becomes this log of 8, log base 10 of 8 raised to the 1/3 power. Okay, we just talked about this on your warm-up today. If it's raised to the 1/3 power, what kind of root is that? It is a cube root, and I put it back on the wall. It's over there by Christian. When I see x to the 1/3 power, it's a cube root. So cube root of 8 is 2. And remember, you can also type this in your calculator, 8 raised to the 1/3 power. Your calculator will do that. So we'll Decimalist calculator. Log 2 then is the final answer, okay? Bless you. Now we're expanding. Bring the 7 out in front. It becomes 7 log base 2 of 8. There's going to be a lot like this in Delta Math where it has you do like the addition or subtraction rule first, and then you have to move the powers, all right? Okay, number 17, you've got, your exponent is x minus 1. So when you bring that out in front, there's already a 3 there. What do you think you're going to have to do? Yeah, you'll have to distribute or put it in parentheses. So x minus 1 goes here, and it's not like the worst thing in the world if you were to just leave it like this. Honestly, that's probably fine. If you wanted to distribute it and take it a step further, just make sure it stays in parentheses since it has 2 terms. So it would become, you could also write it as 3x minus 3 log 4. All right, and then your last one, again, another good review of roots and exponents. This one doesn't have an exponent, at least not that you can see, but it does. When I have a square root, what exponent is that? Not 2, 1/2. Okay, so over here on the wall, remember when I have just a regular square root, that is the same thing as having an exponent of 1/2 is always a fraction when you have a root. That bottom number is what is in the crook of the index. So then that 1/2 comes out in front, and it becomes 1/2 log base 7 of w. Then you're done.